All right, ladies and gentlemen, this will be the second example on your worksheet that you got. We have two velocity vectors in this case. Okay, one of those velocity vectors is at 2.00 meters per second along the x-axis, which is super nice for us. All right, so that's what V1 looks like. V2 looks a little bit different than this, however. V2 is 5 meters per second at 45 degrees below the positive x-axis. So we're looking at something like this, right? So this is our V2 vector. Now, one nice thing about this is that V1 is all x component. The Vy x component in this case, the Vy component is 0. Alright? So we really don't have to do much calculation for this one. We'll just say that V1's x is, well, it's the same magnitude as V1 in this case. It's 2.00 meters per second. V1's y is 0. It's nothing. That's the line through there. Okay? So V2's x is really the one, x and y components are really the one that we have to analyze here. So there's x, y, okay? Our resultant vector being here to there. A little curved on this one, it's so it goes. Alright, so one thing to note about our final velocity vector here is that its y component is in the negative direction. And you can see when we do this graphically that its y component is very nicely going to equal V2's y component. Right? We've got V2's x, V2's y here. And this is the angle that was indicated to us. Theta 2 in this case. Again, V1 already in its components. V2, we're going to have to break that into its components. Nicely enough, it's a 45-45 triangle again, so the x component is equal in magnitude to the y component, even though they're not in the same direction. Which, mind you, means that they are not the same vector. They're not equal vectors, they're not equivalent. Okay? So if we find V2's x, V2 cosine of theta, and we'll put in some numbers into there. We're going to get a value of 3.5355 something. Mind you, these are meters per second. Those are the units of velocity. Now we have to be careful when we do V2's y, because remember that V2's y is in the negative y direction. So it's analogous to that one there, but it's a negative value. We're going to get negative 3.5355 meters per second in the y direction in this case. So adding these, not really difficult. You can do this one in your head, I think. I'm going to. Alright, so, sorry, it's purple that we want. Alright, so the x component of V1 is just, the x component is V1's x plus V2's x, which is nicely, again, 2.00 meters per second plus 3.5355 meters per second, and V's x is just 5.5355 meters per second. Vy is a little more than that. Well, sorry, no it's not, because V1's y component is 0. So we're adding negative 3.5355, etc. meters per second there. So Vy is simply that. Okay. Now again, of course, we're going to use the Pythagorean theorem with these numbers to find the magnitude of it. The magnitude of our resultant vector, that is. So the x component in this case is, what was it? Oh, yeah. 5.5 plus so the magnitude of our resultant vector in this case is going to be a positive number, right? Because remember, the magnitude is always positive. In this case, it's 6.5682 something. We're going to round that, I guess. 3 digits is always nice. 6.59 meters per second. Again, we have to use these same values that we got before with the inverse tangent to find the angle. So Vy in this case is going to be negative 3.5 per second over positive 5. Right, so theta ends up being, in this case, negative 32.466 degrees. We'll round that as well to 3 digits. Okay, so remember that, nicely enough, if I just use the negative sign there, that will carry the negative sign into this here. You do still have to pay attention to which quadrant your vector is in to make sure that your calculator has given you a correct value. Okay? You would get the same value if it were in the 3rd quadrant. Okay? In which case, recording this number for it would not be accurate. You would have to say it is 32.5 degrees above the negative x-axis, or you would have to have 32.5 degrees to 90, so it would be 192.5 degrees. Sorry, 122.5 degrees there. So just pay attention to how you report your value and what quadrant your vector would actually be in.